Hello everyone, KeyGrabter here with another Java tutorial, and today we will be looking at variables. So before we start, what is a variable? A variable is so it's like if you see, so probably the best way to explain it is to look at maths. So look at y and x, for example. I assume if you're watching this video you probably will know about y equals mx plus c. So y, x, m and c are variables. They can change, so the gradient can change in a graph, the value of y can change, and the value of x can change, and they are stored across the graph. So like x is stored by the x variable, y is stored by the y variable. And programming has this whole idea as well, except you can do this with a lot of things. You can do it with numbers and characters and boolean values and the like. So today we're going to cover them and how to display them and muck around with them and use them in a useful manner. So the first, most basic, the most really useful sort of data you want to use for your variables, they're called data types. So it's what type of data the variable accepts, is integers, which are denoted by just int, and we'll call this even. We'll set this equal to 1. What this does is it creates a variable called 1 in memory. So it's just a blank memory address, 4 bytes wide, which is referenced in the program by the name 1 and gives this block of memory the value of 1. Simple enough, hopefully, for you to understand. Now, this can be applied to a lot of things I've said, and we'll demonstrate this throughout the video. So we've got another variable type called short. The difference between short and int is because they can hold the same values, is that short uses less bits than int. Int by default uses 32 bits, whereas short can use 16. 16, since there is no unsigned measures in Java, limits this to a maximum value of 32,768, whereas int is limited to around somewhere in the region of 2 billion. Unsigned would mean that it goes straight from 0 to the maximum value, whereas signed, which is the default for all these values, means that it goes the other way, negative as well. So you can get a negative value of around 32,767 with a short. The next type is byte. This does basically the same thing as short, but byte to short is like short to int. So, probably should give that a name. The 8 variable mean this value here has a maximum byte width of 8, limiting it to negative 127 to 128. This is really useful when you haven't got much space, although to be honest, if you haven't got that much space in memory, you should be using C or assembler anyway. But where you're forced into using Java in a low memory environment, you should probably use bytes or shorts wherever possible. So the last one is long. These hold pretty damn big values. This can hold up to a maximum of 2 to the 64 different numbers. So it's I think it's 2 to the 63 both ways, really. So that's about 8 untillion values. So if you've got, you don't have to worry about space because these are 8 bytes as opposed to this where it's 1. You can use this and you can get some bloody massive numbers. So these are all the basic sort of integer values, because these can't hold decimals, for example. Whereas with this, you can hold decimal values. So float is an abbreviation of floating point, which means variable sort of decimal places behind the number here. This holds the value of pi to, I think it can hold it up to a maximum of about 6 or 7 different decimal places, so good for most purposes, although you've got to keep this f on the end or it causes errors. But you can do one better, and that is with a value called double. So you can get far more decimal places. I think it's around 16 or 20 with this. So yeah, it can hold a lot more values. I don't think it'll hold that entire number, but it can hold at least up to about, say here. This is for holding. This is for where you want real real precision with the numbers you're recording. Because well, if you say for example you're recording, say, the refractive index of a material and you want it to be very, very precise, so like if you want to compare a vacuum to air, you're going to want to use a double as opposed to a float, because the refractive index of air is basically the same as a vacuum until you get to about times 10 to the minus 8. So you want to use double as opposed to float in that situation. Whereas float is just for general use, like if you're going to write basic pi or something. So that could be 3.142, it'll hold that. Then we have our character values, so it will hold a V. It holds an individual character, and that's it. It will hold, I think they've changed it to Unicode, although it might still be ASCII. I believe it's Unicode or ANSI that they use as the default value, as a default, like Charles said, for Java, although you'll probably have to search that up yourself. I know for a fact that in C they use ASCII, and older versions of Java may use ASCII, but for this I think it's Unicode. Now, what about if we wanted to use more letters without creating an array? We'll get into arrays later. Simple. A string is just a array of characters. Well, it's a special way of arraying characters. It's different because the observant amongst you may have noticed that this isn't highlighted like the others, and that's because this isn't a primitive data type in the same way these are. This is actually a class like this, but included with Java, and you can do lots of cool things with this, which we'll probably get onto in a later tutorial as a result of this. Now there's one final sort of value you want to cover. A boolean is just a true or false value. So for example, my computer switched on would be true, it's raining outside would be false, I don't know, I can draw equals false or something. So that's basically an overview of most of the variables, but can we do anything with them, like reassign values? Of course we can. So we could change pi's value, make it F is very important on the end of the rows as it causes errors. You can just do that with anything. You can put this here and reassign these to anything, although you might not want to change them, and if you don't want to change them, we'll show you how to stop people changing them in a later tutorial. If we want to do addition and subtraction and any of the other basic sort of mathematical operations with it, it'd be very simple as well. So for example, if we wanted to add something to 1, so go 1 equals, we just do that. So now 1 is 3. Mind equals fucked. So that's basically, you can do this with division, subtraction, so like if you wanted to divide times would be that. You can also do it with modulo division, which we'll cover later. Now, it's all well and good that we can do this, but how do we display these variables? Simply, just use system.out.println, as we learnt in the, when I can spell, in the initial video, and we can type the name of our variable. So if we want to output pi, let's do pi 2. We'll be able to see how many decimal places double can go up to that way. This will just output the variable and then put a new line at the end. Now what about if we want to put some text with our variable? Well, that's simple as well. Very simple, so we just put a plus here, and then put whatever variable you want in the end, so put hello here. Hopefully very simple to understand. If you've got any issues, just ask in the comments. If this causes no errors, yep. So we know how to run it. So yeah, it can go a long while. So what's it go through? 592. Five, 3, 5, 8, 7, 9, 3, 2. So about here. So it can go up to, what's that? 1, 2, 3, 4. About 17 decimal places I count. Well, 16. Go figure. So yeah, that's basic variables. Thanks for watching. Any questions, obviously ask in the comments. I'll get to them as soon as I can. In the next tutorial, we will be looking at comments and JavaDoc and how that can be incredibly useful to moving about your code and having people understand your poorly written code. Thank you and goodbye.